Okay? So today what we're going to look at, is we're going to look at the perpendicular bisectors of triangles. Okay? Now what do we mean when we say the perpendicular bisectors? Well, we mean the perpendicular bisectors of the sides of a triangle. Okay? So there's three sides to a triangle, so we're going to look at three perpendicular bisectors. If you take a look at the picture here of this triangle, okay, you can kind of see how many perpendicular bisectors are drawn. Anybody?
Two.
Yeah, there's only two actually drawn in. Okay? So, Matt, can you name one of the sides that has a perpendicular bisector drawn in for this triangle?
QR.
Okay, QR does have a perpendicular bisector drawn in. Okay, and then Julio, can you name another side that has a perpendicular bisector there? PR, that's right. So QP is the only one that does not have a perpendicular bisector drawn through it. Now, you'll notice that QR and PR intersect at a point here. And in fact, if we were to do the perpendicular bisector of QP, that third perpendicular bisector would also go through point C, or it should if we're very precise with our measurements and stuff. Okay? Now notice this point C, if you were to take your compass, okay, and put that compass point on point C, and then kind of close up your compass some so that the pencil point would touch the outside edge of that circle there, okay? C is the center of this big circle. Ooh, and my pencil is like way too. There we go. Okay, your compass point would go around that circle and touch. And what does that circle touch? What does the circle touch on the triangle there? All three, yeah, of the points. All three of the vertices of the triangle. So that means the distance from C to D, or sorry, C to D, wow, C to Q, the distance from C to Q, how does that relate to the distance from C to R? It has to be the same. And then how about the distance from C to Q to C to P? It'll be the same distance, right? Okay? That distance is going to be the same from C to Q to C to R to C to P. They're all the same distance, okay? Those are all like a radii or a radius of the circle, and so they're going to be the same measure, okay, because the circle touches all three of those points. Okay? So, that is the idea there. Excuse me. And this is kind of like how the idea of I think like triangulation works, like locate where people are and stuff like that. Okay, to a degree, like GPS satellites. When you guys are like trying to find directions or something like that, this is how like your phone kind of knows where you are to a certain degree. It uses circles like this and uses satellites to kind of like figure out your position on the Earth and give you like a coordinate. And I think it uses something like this in a more complicated kind of sense, but that's it. Okay, so. This process here, okay, this circle is a circle that contains all the vertices of a polygon. In this case, this circle contains Q, R, and P, all the vertices of this triangle, is circumscribed about the polygons. That means the circle goes around the outside of the polygon, right? When you know, like, I think Magellan, right, is always, like, famously known for, like, circumnavigating the globe. That means he navigated around the world, right? He sailed around the world and stuff like that. So this circle goes around the outside, okay? Let's see here. So in the figure, circle C, so circle with center C, is circumscribed around, oh, Derek, I'm sorry, I did not want you to go back there. I wanted you to stay up front here. Thank you. Okay, so please come on back and bring your book with you, please. So this circle is the circumcircle. Circumcircle. It's the circle that goes around the outside and touches all the vertices of our triangle. And then C itself is called the circumcenter because it's the center of that circle. Okay? So let's maybe label that here. So this is the circumcircle. Okay? Point C is the circumcenter because it's the center of the circumcircle. It does kind of like add a bit of complexity to it. But the word circum just means to go around. Okay? So there it is. We're not going to worry about filling in all these blanks here. It's just kind of silly. We're just going to go right into actually trying it there. So this is the circumcircle, and then the circumcenter is point C, found by the perpendicular bisector.
That's what we're doing right there.
We're going to do this, yeah. Mm-hmm.
Is that all we're doing?
We're going to answer some questions about like measurements and stuff too, but that's the biggest. It's two angle bisectors, yes. Mm-hmm.
Are we proving the circumcenter?
No, we won't prove it, no.
Alright, good.
No, but I do want to take a look here real quick. So we could prove this, okay? In this explain here, it says proving the concurrency of a triangle's perpendicular bisectors. Now, concurrent just means it's like lines that intersect at more than at the same point. So the perpendicular bisectors of a triangle are concurrent. They all meet at a specific point. In this case, they're indicating point P. That's the circumcenter. Okay. There are other constructions that we'll be doing to find a center of a find the concurrent point of a triangle. Okay, but a point of concurrency is just where three or more lines meet. Okay, so in this case, our perpendicular bisectors all meet at point P in this picture. Okay, and we just talked about this. If P is the circumcenter, okay, it's where all the perpendicular bisectors meet, then point P will be the same distance to A as it is to B as it is to C. So PA is equal to PB is equal to PC. Okay, because this is like the center point, and the circle would go around and intersect A, B, and C, and they'd be equal distance. Okay. Question you came?
It doesn't look like.
It doesn't look like it? Well, we can kind of, let's see here. We have our compasses handy, right? And so if we put our compass point on point P, and then I close my compass so that it just touches vertex A, if I kind of circle it around here, ooh, you're right, it does not quite look like
Oh, boy.
it does intersect here. So I'm guessing that this is probably just like a kind of a quick drawing here, but it doesn't look like it doesn't look like you're right. It doesn't look like it hits B or C. It should hit B and C. So I'm guessing this is probably just like a picture, and it's not maybe drawn to scale, but it is true though. Okay. So, shoot, I wanted to draw more here, but I thought there would be some actual practice. Maybe not. Okay, we'll get some practice here. In fact, before we get into using the properties, I do actually want to do a perpendicular bisector. So we'll skip this page. We'll come back to it. But let's go to page 363. I want to say yes. Okay. This is finding a circumcenter on the coordinate plane. Okay, and we're actually going to do this using our compass and straight edge, and not excuse me the method they're going to talk about here. So let's kind of identify here where our points are. So we have R, which has coordinates -6, 0. So there's point R right there. Okay, S has coordinates 0, 4. So there's S. And then O has coordinates 0, 0. Okay, so we're not going to do what they're telling us to do here. We're actually going to draw it in. Okay, they already have a perpendicular bisector drawn right here, it looks like. Actually, they did this one already, didn't they? Yeah, there's a perpendicular bisector for this side. Okay, they drew it in already. There's a perpendicular bisector for side SO. Okay, so that is our circumcenter. I'll go ahead and label that right there, okay? We'll actually do one here in the next one below. Okay, but there's the circumcenter.
How do you do the
We'll do the construction. Don't worry, like they calculated out. We're just going to be doing it using the compass and straight edge, and I'll show you here once we get to a problem. I think letter B will actually be an actual problem there. Okay, but what we should be able to do is take our compass and straight edge, put the point on the circumcenter, open up the compass to one of the vertices of the triangle.
So R?
Yeah, R or S if you wanted to, and it should circle around. It's kind of hard to circle around. If you want to, you can kind of turn your paper if you need to. Okay, but it should circle around and hit. Yes, it does. Look at that. O and S.
Oh, yeah, Jay.
Oh, yeah. Okay. So it's tough. I understand. Like I said, maybe consider turning your book. If you're having trouble getting the compass to go the whole way around like that, consider turning your book some to then get the little pieces and just get it all in. Okay.
So, Mr. Wynn,
Question, yes.
will we ever get, oh, no, not good. Will you ever get a problem that, doesn't touch all
It should. If you do your construction correctly, it should hit all three sides.
Because, you know how, when we were naming, side, and
Right.
equal side?
Mm-hmm.
And sometimes it can be,
It wouldn't be congruent at all, right? So no, here the circumcenter, if you construct it correctly, will always go around the outside of your triangle like that.
And where's the circumcircle? Would that be the
So
square?
that is what I just drew in here. This thing, this circle that we just drew is the circumcircle, if you want to label that. Okay, it's the circle that goes perfectly around the outside. Okay. And it's kind of hard to do, but yeah, if you kind of something like that.
I didn't mind it either.
It's not, yeah, you get better at it as you try there, as you work with it, so. But that's the idea. Oops. Okay, so let's actually finally do one, okay? So let's go down to this bottom one here. Let's plot these coordinates for the vertices of our triangle. So A has coordinates -1, 5. Okay, B has coordinates 5, 5. And C has coordinates 5, -1. Okay, and let's use our straight edges then to connect those dots. Make nice straight lines. Bless you. Okay. Now, to find the circumcenter. Okay, to find the circumcenter, that special point. Remember the circumcenter, we use perpendicular bisectors. They find the circumcenter. Okay? So, in order to figure that out, we're going to take our compass and we're going to pick a side to construct a perpendicular bisector. Okay, so let's do AB. That's probably the easiest one because it's facing us, okay? So when you're going to do the perpendicular bisector for AB, you ignore AC, you ignore BC. We're only going to focus here on AB, okay? And so remember, to construct a perpendicular bisector, that is the football construction. So you're just going to take your compass, put it on point A. Okay, make sure your compass is open up, over halfway, a little more than halfway, just like kind of mine is there. It doesn't have to be the same as mine. And then you make one big swoop. And then without opening or closing your compass, you're going to put the point on B and make another big swoop. Okay, I should zoom in on that some maybe.
Can you do it again?
Yep, I'll do it again. So again, if I want to do the perpendicular bisector for AB, I'm just going to pick segment AB here, just like we did in the warm-up. Put my compass point on A and do a big swoop. Yes, it might hit AC or it might hit BC. That's okay. We don't care about that. We're just trying to make the big swoop. And then without opening or closing your compass, put the compass point on B, and again, big swoop. Again, it might hit other stuff. We don't care about that, though. We need these two things to intersect, the two arcs to intersect there, like that. Okay? And then in a different color here, I'm going to do a different color just so you guys can see it better. Actually, I'll do it in pencil. That way, it's just I'll just use pencil. Okay? We then draw the line, lightly draw the line. You don't have to make it super dark, but lightly draw the line that connects those two crisscrosses in our construction. And wow, this is you don't have to, but because we're not interested in the midpoint, but that is the midpoint though. Okay, so there's my perpendicular bisector, my first one. How many more do we need to draw? We could do two more, but we only need one more. We only need one more. You could do both sides because we know that all three sides are going to intersect at the same point. So once you find two of them, then you have that point of intersection. You don't need to do the third one. So I'm going to recommend that we do side BC here. Okay? And I also recommend, if you're going to do side BC, that you turn your paper so that BC is facing you. So we're going to do the same thing, but now to BC. Okay, so go ahead and take, 30 seconds there and do the same thing to side BC. I would recommend you adjust your compass some too. Don't use the same measurements you did for AB. Adjust your compass differently there. So I'm going to look at, I'm going to look at segment BC. I turn my paper so I have BC facing me. Okay. I'm going to adjust my compass to be a little bit more than halfway. I'm going to do another arc from C, and then compass point on B, and an arc. A swoop. And you can see there's an intersection point, and then there's the intersection point. You can see this gets a little confusing, doesn't it? Because we have all these swoops in there. We got to keep our swoops straight. Okay.
I can't even draw this thing that.
There's not no way. You can do it.
Because if whatever this is not saying, it's going to go over.
Okay, and so there, where our two perpendicular bisectors intersect, right here on my triangle, that's my circumcenter, right there, where the two perpendicular bisectors intersect. So it's about a coordinates 2, 2. About coordinates 2, 2 there. One second there, Ikeba, let me get this straightened up. Okay, so questions. Yes, Ikeba?
Will you look at my book?
All right, one second, let me finish with the rest of the class, and then I'll come and take a look, okay? I will.
That's my question. Like, I don't have a midpoint. I mean, I don't have a point that matches up.
So, are there any more like this, Ramel, in there? I would use these, okay? Because that one you just adjust the little locking mechanism there. Okay, so there's our point of intersection, about the coordinates 2, 2. I'll come take a look here, Ikeba, in just a second. I'm going to finish this up because we're not quite done yet. Okay, so this is the circumcenter. Now, to show that it's a circumcenter, what am I going to do with my compass? I should put my compass point on what? On this circumcenter right here, and then open it up so that it just touches like point A, for example, and then it should make a circumcircle. And let's see. Okay, and if you look at that, sure enough, it does hit all my vertices, pretty much. It's not quite hitting C, but it's pretty close. Okay, and it's kind of hard to do, again, if you want to like turn your paper or something like that.
It looks like a flower.
But there's our circumcircle.
I mean, mine doesn't, but yours does. I like them red.
Okay? Questions on any of that? Okay. So we'll do another one here. Let's turn the page. I want to practice it again once more so we can get this down. Let's try it on triangle. Let's see. We have some more coordinate ones here. Let's do that. So turn the page and look at number 8 here. Okay, we'll just try it with here on number 8. Okay. So go ahead and give 8 a shot. I'll kind of catch up here just one second. Let me take a look at EK. So go ahead and go ahead and at least put the points down for triangle.
I mean, I marked the point to do with around 2, 2, but like, I didn't know.
Okay, so if you look here, this perpendicular bisector is sitting down okay, but you kind of like want it to skew a little, like it's a little tilted, it should be more.
Oh, it's
It basically should be like that.
yeah, but like, mine was the middle with that line.
Well, I see what you're saying, it's that, but then when you see how like these intersect, you kind of want the right of your point of intersection.
If I don't get it, I'll.
Question?
Gentlemen, look, I am not paid to your parents, okay? So
Yeah,
you can't
God.
stop touching each other. Dominic, how about you move over this empty seat here? That way we don't have to worry. All right, well, if I hear arguments again, it won't be a choice. I'll be asking you to do it. I agree.
Yeah.
Oh, yeah, your pen looks like this. That's why she has to shoot down the little...
Mine is really tiny. and it's still doesn't.
Yes, kids.
I don't remember
Okay,
doing
you
that.
know how to hold this.
I know. Oh, yeah.
There it is, just right through it. Well, because your pencil, like, was like...
But I'm not very good at like.
Mine's tight and you can put that.
I don't
No,
know.
that's not. You gotta pull down the center. Now.
I'm like act out.
All right, gentlemen, let's go. Come on, let's start on this one right here. Number 8, let's go. Okay? Get it going.
Now I want you number 8.
Let's get it going.
Derek, don't help me, please.
Okay, look.
Don't need it. And in fact, it makes it worse.
So I drew my one thing. Where
Derek,
did
you understand? Shh. Did you get it done, Derek? You're not done. Come on, keep going. You can. If you think you got it, keep going.
So is this line so they can bind like?
Perpendicular bisector for that side. Yep.
Oh,
That's
it's
it.
not even on it.
All right. So I'm gonna get caught up to you guys here, and then we'll kind of take questions and things. Okay. So Q has coordinates -4, 0. So there's point Q. Okay. R has coordinates 0, 0. And then S has coordinates 0, 6. Whoops, I call that S. Okay. And let's see here, SQ, and then QR.
I just need to move with my feet.
Okay. Yeah, if you need to turn the paper instead of the compass, that also works too. I mean, do what you need to do there to get that circle drawn in. Okay? A couple things here real quick, guys. If you are using this compass, just to kind of give you a heads up, if your thing's moving all around on you, check two things. First, you need to make sure that this gray piece right here is screwed tight, okay, against the pencil so it holds it in place. Second, you also need to check this right here to make sure that it can like slide up, and then that makes this very, well, not very loose for me, but it would be looser, okay? So that can make it loose. If you push down on this, it tightens it, but now mine's like, I don't know, that's weird. It's like tight no matter what. So I'm not sure what's going on there, but interesting. Well, anyway, so it'll hold it in place, okay? So this thing tightens, like, so it doesn't like slide this way, and this thing tightens so it holds the pencil in place. You need to make sure both those are tight so it's not going to slide all over on you, okay? Now, perpendicular bisector, back to that. Okay. Pick a side. I'm going to go with QR because it's right there in front of me. Okay, I'll put my point on R. Needs to be a little bit more than halfway open, and then just big old swipe. And then put it back on Q, and a big old swipe. Okay, you can see the football construction there. And we just draw in the segment. Okay, like so.
Mr. Wade, I made my side bigger.
Okay, your arc's bigger. That's
Yeah,
fine.
But
Should be the same thing. It should go vertical line through about -2. And then turn your paper. And we'll do this other side here. I'm going to open up my compass a little bit more than halfway. Big arc. And then big arc from R. Okay, and then we'll connect the dots, or connect the arcs where they intersect, right there and there. Okay.
I got it.
There it is right there. Okay, and so Xander, about what are the coordinates there for our circumcenter? Yeah, about -2, not 2, -3, I'd say, -2, 3. Okay, for the coordinates there. So once again, EK will be right with you. And so let me just color that in. Oh, where'd my pen go? There it is. Okay, so -2, 3, right there is my circumcenter. Okay. Okay, circumcenter. And then we can again show that that this point is equal distance from QR and S by drawing a little circle in. So put your compass point on that circumcenter and then open up so it just touches like Q or R or S, and it should kind of circle around. Like so. Okay, you can see the circle touches Q, R, and S. So that means that point is equal distance, okay? It's equal distance to Q, to R, and to S. Okay? So there it is. All right? Questions on any of that? Yes, you can.
so like I drew my shape and it like matched up to a point. But is there a way you can find the point? Cause like this, I know it's confusing, but like both of my football shapes matched to one point, but I couldn't find it until you said what the point was.
It doesn't have to go exactly on the point. It's more important that you do the constructions, you know, just as accurate as you can, and then try and get that get that point to let you draw the circle there. So I mean, you said you weren't able to draw in your perpendicular bisectors. Is that what you're trying to say?
No, I found the point.
Gentlemen, I'm sorry. What's going on here? Why are we having a conversation?
Oh, sorry.
Okay, thank you. You need to be listening right now.
I found the point and I drew a line, so I'm asking you to a way to like find it. Cause like for example, like the football shape between like segment Q and R, like that point isn't even in the shape. Like, and you would think it would be in the shape.
Q and R. So this right here.
Right, like the point, the
Circumcenter right here? Okay, I'm sorry, what was the problem with it not being on?
like it's not like on the shape.
Sometimes it won't be on the shape. In this case, it is on the shape. It should be right on the line QS there, but sometimes it won't. The circumcenter won't be on the shape.
But it'll be like in like the line that connects them.
Again, the perpendicular bisectors where they cross, where this perpendicular bisector intersects this perpendicular bisector, that is where the circumcenter is located. That's where the perpendicular bisectors intersect. Okay, just like we go back to the very first one that we saw here. Okay, Josh, Dominic. Okay, Derek, don't need your help either. I know, he might have to stay after lunch, stay with me for lunch sometime so I can teach it to him. All right, Derek, so I need you to cut it out though, seriously, because it doesn't help, it makes it worse. People don't have to listen to you. Okay? So, right here, Ikeva, right here, the perpendicular bisector for PR, and there's the perpendicular bisector for QR, they intersect within the triangle, inside of it. Okay, and sometimes the perpendicular bisectors will intersect outside the triangle too. So it's just a matter of drawing those perpendicular bisectors, seeing where they intersect, and that is your circumcenter. Don't worry so much about where the point ends up. Just trust the constructions. Okay. So the circle is made. Well, how do you make a circle using your compass? You just take your compass point, put it at the center, and then we know that this circumcenter, the circle should touch Q, R, and S. So just open it up so that it's the distance, the distance to Q, and then just circle it around, and it should hit all the points. Okay? So yeah, let's try number 9. Let's try another one here, Ramel, so you can see that one. Okay, let's try one more here. Let's try number 9. Okay, so try using that compass, Jordan, if you had some trouble. Those are a little bit better, I think. All right? So we'll plot these last couple points here. So 1, 1. It's point K. 1, 7. There's point L. And then M is 6, 1. Okay, and then we'll connect the dots. Okay. All right, so there they're drawn. Okay, if you're having trouble, then just wait for me. Don't rush on. If you're having trouble still, just wait for me, okay? So there's our triangle. Has anyone still drawn the triangle? We're all good there? Okay, so then KM. This side right here is what we're going to bisect. So I'm going to take my compass. All right, I'm going to put my compass point down on point K. See, you guys can see that, right? We're going to open up a little bit more than halfway. And then we're just going to do a big old swipe. Okay, like that. Okay, and then without opening or closing the compass, we're going to put it on point F and do a big old swipe. Like that, if you want some help. So what you need to do here is loosen up, unscrew that some, then your pencil can fit it. And then you screw it tight, and that won't move on you. Okay? And then we're going to draw on that perpendicular bisector using our protractor here, and I'm going to use my pencil. Okay. So it looks like here my perpendicular bisector is not quite on 3 and it's not quite on 4. It looks about 3.5 in this case. It's going right through there. Okay. Oh, the coordinates. Okay, I'm not to that point yet. Okay, I'm not to that point yet. But it looks like it goes through about 3.5 there for me. Okay? And I'm going to do the same thing, right? I'm going to pick this side here, LK. So I'm going to turn my paper. I recommend you do that too. And then we'll do the football construction here as well. So again, open your compass up a little more than halfway. Do a big swoop. And then on K.
We don't change the measurement.
You can, Ramel, for each like perpendicular bisector, you can adjust it, but keep it for the same perpendicular bisector. You know, you keep the same measurements. Okay.
This is 3.8.
Okay, and so there's my point of intersection. I got about like 3.5, 4 about-ish, right in there, though, is the point, is the circumcenter. Right about there. So about like 3.5, 4. Right around in there. Okay. So there she blows, and then last step, right, we're going to put our compass point on that point of intersection, and then circle around. And mine, ooh. I didn't do a fantastic job here. Okay, see, even me, I still get like a little bit, it's not quite hitting through L there, but it does hit through K and M, okay, so it's not going to be perfect, but it's the right idea, though, okay, it should be this point, okay, I'll call it like point P, so P to L, P to K, P to M, how should all those distances compare? P to L, P to K, P to M, how should all those distances compare? They should be what? The same length. That's exactly right. So PL in this case should be equal to PK, should be equal to PM. Wow, I just wrote M twice for some reason. Okay, I'll just kind of fix that by drawing it really big. Okay. So PL should be equal to PK, should be equal to PM. Okay, and those. Because it's the center of a circle that touches all three of those points. Yes, Ikeva.
So if you didn't have a graph with you, like
Yes.
you wouldn't be like,
If it was just freehand,
you would just wing it?
yeah. You wouldn't just wing it. I mean, but the same construction. Same construction. Okay? All right, one more thing I want to look at here, and then we'll get you guys into your assignment. Okay, let's go back to page 361, now that we've talked about that, and then we'll be done. You guys can start on your homework. Okay? So, now, on page 361, you'll look and you'll see that we already have our special point drawn for us, right? Point Z, if you look here, right, it says that KZ, LZ, and MZ are the perpendicular bisectors of triangle GHJ. So, there's KZ, LZ, and MZ. Those are all perpendicular bisectors, and so that means point Z, what can we call that? The what? Circumcenter, that's right, circumcenter. So Z is the circumcenter.
Wait, the perpendicular what, Mr. Lid?
So KZ, LZ, and MZ are the perpendicular bisectors of triangle GHJ. So that means KZ, LZ, MZ, these are the perpendicular bisectors. You don't see the construction marks, but that's what they are. We're told they are. So they weren't constructed, they were just given to us. Use the given information to find the length of each segment. Note that the figure is not drawn to scale. Okay, fine. So it says here ZM is 7. So using my pencil, I'm going to put a little 7 in here for the ZM. And I say pencil because we're going to do some other measurements here later and where they're going to change. Okay? So put a little 7 in here for the ZM. Okay, ZJ is 25. So Z to J is 25. And then H to K right there is 20. Okay? From here to there, and then from there to there, and then 7's like from there to there. Okay. It says find ZH and HG. So let's see here. So here's Z to H. Here's Z to H. So with the way this picture is marked, and the fact that we know that Z is the circumcenter of this triangle, what does the distance from Z to H have to be? Anyone want to volunteer, raise their hand and tell me? What do you think here? So, Zaria, what do you think? Okay, not sure? Derek, what do you want to say? 25. 25. How did you know that, Derek?
It's the same as Z to J.
Exactly right. Guys, remember, Z is the circumcenter. That means it's the same distance from all the vertices. So if Z to J is 25, Z to H is 25 as well. What other segment will be 25 here, Ikeva? Z to G will also be 25. Now, that's not asked of us, but yes. So ZH here is 25. So So sorry, that's good. Even though you had the wrong idea, you knew it was wrong and you stopped yourself, and that's good too. Okay, so that still shows some good understanding there. Okay, all right. HG. From H to G, what would that distance have to be? Any ideas here? From H to G. H to G. Anyone want to take a guess? Maybe someone decides to cave. I'll come to you and cave. No one else. If no one else, but I'm going to see. From H to G. Anyone else? Derek, too, I want to get someone else. Anyone new want to say here? From H to G, what do you think that distance might have to be? Taylor, what do you say? Yeah, 40. How'd you get that? Yeah, so KH is 20. KG is going to be 20 as well. Why? Because what is KZ again? KZ is a perpendicular bisector. So that means KZ bisects side GH. So if KH is 20, that means KG is also going to be 20. So HG then will be 40 total. That's the idea there. Okay? So that's the idea. We won't do that next one. I want to get you guys started on your assignment here. So let's flip over back to the pages there. Okay, on 365. Okay, and so what I would like you to do, let me see, what did I assign here? I think I put it right here. Oh, I didn't. Okay. Let me go check which ones I assigned real quick, and you guys can start on those. Okay. All right, so I think I want to do 1 through 6. 1 through 6, please. 1 through 6. Okay, so please do get started now because you need compasses, and I can't let you take these compasses home. So please do get started now. At least get 1 through 4 done.
Did you say 1 through 5?
1 through 6. 1 through 6. So 365 to 366. Okay. 365 to 366, numbers 1 through 6. Please try to get 1 through 4 done now because I can't let you take these home. I need to hold on to these.